All right, so this is the next lesson of sinusoidal expressions and functions, or graphs and equations, I guess. So we're looking at the characteristics of it in this one. And so this one will be a little bit different. So as it says at the top, it says, as you saw in the last lesson, the sinusoidal equations on your calculator are represented in the form y equals a times the sine of, or sine, and then in brackets, bx plus c, close the bracket, plus d. Each letter in this equation corresponds to a particular characteristics of the graph, the median line, the period, the amplitude, or a horizontal shift. And so what it means by that is A, B, C, and D. When we change those, it actually changes characteristics of the graph. So what I want you to do is the next 1, 2, 3, 4 pages look kind of similar to start. And so what you need to do actually is pause this video, and what you need to do is put each of them in your calculator and fill out the table below. So the first one, it always has the first 2 graphs done for you, and then it will have 2 more graphs that you need to complete. So here, what you're going to be putting into your calculator for this one is just y equals sine, it'll open a bracket, and just put x in there. And then you need to graph it out. So you need to put it in your y1, I guess, and graph it out and see what it looks like. So quickly, if you need to pause, put that in, and you should get to a graph that looks like this one. You might need to adjust your windows to have it look similar. So as far as what your window setting is, probably your x values between, I don't know, -5 and +10, so your minimum and max. And then your y values, in this case, you could probably go between -2 and +2 for your minimum and your maximum. Just get your window settings. And then, so again, this first graph is drawn for you, but what you could look at based on the graph. So again, your maximum looks like it's at 1, your minimum looks like it's at -1. So the median line, it's represented by kind of this dark line here. The median line is at the line y equals 0. The amplitude is 1 unit. So again, amplitude means how much does it go above the median line and how much does it go below the median line. So the amplitude is 1 unit. The period, it's kind of hard to tell just by looking at it, but the period is how fast does it repeat itself. So I kind of have to erase what I've drawn here. So if we look, again, we called this the starting point. So the middle part of the up swoop, it's called the starting point. So the starting point is on 0 right now, and then it looks like the next time it hits a starting point is here. And so that's actually 6.28 units. You could calculate that out again, probably is the easiest to track when it's at a maximum and when it hits its next maximum. It's off the page here, but the graph would go up there. And then subtract your x coordinates of those 2 maximums or 2 minimums, and you will find that the period of that is 6.28 units. We'll talk about why that number is kind of significant. And the last one, it says horizontal shift, yes or no. So the way that you can tell if there is a horizontal shift is based on the starting point. So again, the starting point, I just kind of talked about it. The starting point, if you take your graph and you're on the up swoop, where the graph is increasing, the starting point is your midline. If the starting point falls on your y-axis, so starting point is on the y-axis, meaning it's not shifted to the left or the right, that means there is no horizontal shift. So just to show you what a horizontal shift would look like if we were looking at the same graph, and instead, so that's our x and y axes, if we were to look at a graph that had a horizontal shift, it might go like this. So now our starting point, I can do this. This would be no horizontal shift. This would be a horizontal shift because now our starting point, that's right here, is shifted horizontally, so to the left or the right. So this graph here, again, our starting point is on the y-axis, so there is no horizontal shift. So the next one, just to see, that one's also done for you. Y equals the sine of x, and then make sure you close your bracket here, and then outside the brackets plus 1. And so when you would graph that out, you would get the graph that they have represented here. And so what we want to see is what changed by going from nothing to plus 1 here. And so doing that analysis again, the median line, now the median line is at y equals 1. So we see our maximums at the line, or at the point 2, our minimum is at 0, so our median line is now at 1. Our amplitude is the same, our period is the same, and there's still no horizontal shift. So that is what looks like is being changed. So now what I want you to do is pause the video and do the next two graphs. So the next graph says y equals the sine of x, subtract 1. Again, make sure you close your brackets. So graph that out. Make sure you modify your window as you need and find that graph, and then do the next one as well and figure out those 4 columns at the end, the answers to that. So pause that and see what you get. Okay, so when you would graph it out, oh, I don't know why these are on here. They are not right. When you would graph those out, go away. This one, we see that it goes up to 0. I'm not going to draw this all out. You've already done it. So our median line would be at -1 now. And it will go up and down accordingly. So for all of those, this one, y equals -1, is our median line. Our amplitude is still 1 unit, meaning it goes above or below the median line 1 unit. Our period is still 6.28. So again, the way that you calculate that is look at how long it takes the graph to repeat itself. So between 2 maximums, or between 2 minimums, or between 2 starting points. Still no horizontal shift. And then the next one, when you would graph it out, you can look at my key for some better drawn graphs than what I'm doing right now. So it goes up and down across the median line y equals 2. That's saying same. So our summary for this part is when a sinusoidal equation is written in the form y equals a times the sine of bx plus c plus d, what we've changed in all of these is the d value. So we know that the letter d represents the median line. So d represents the median line. The entire curve will move up or down d units. So now do the same thing with the next graph. So now what we see is happening is we're keeping everything else the same. We're not adding a number at the end. We're not changing D. Now what we're changing is A. So I want you to, the first one's done for you. It's the same graph that we had before, but now we're changing A. So I want you to look at how it changes the 4 columns here. Does it change the median line? Probably not, because we know that D already changed the median line. Does it change amplitude, period, or horizontal shift? So pause the video and do the 3 graphs on that next page. Drink my coffee while you do that. So welcome back. So you've done those 3 graphs, and what you found is as you did the 3 graphs, so the graph for this one was already in your notes for you, and we see that it's changed one characteristic. So here, our amplitude was 1 unit, but we see in this graph, our amplitude is actually now 2 units. So as we changed the A value, remember right now, I wrote 0 there, I was trying to circle it, but right now there's a 1 in front of the SIN, in front of the sign. But now we've changed it to a 2, and what that actually changes is our amplitude of our graph. So now it's 2 units up and down. Our median line is still the same. Our period is still the same. So if we look at the difference from one starting point to the repeat starting point, it's still 6.28. And again, since our starting point falls on our y-axis, there is no horizontal shift. When you do the next one, now we've changed our A value to 3, and then the last one is changing our A value to a half. I don't know what past Tanya was doing with these graphs in here, but let's get rid of them. So when you would do the first one, what you would see is 1, 2, 3, 1, 2, 3. It now goes way up and way down. So on the up swoop. So this is at -3 is our minimum. +3 is our maximum. So the only thing that's really changed is now our amplitude is 3 units. I'm not going to write in all those other ones. And then when we would figure out this one, so if this is 1 and this is -1, this graph will actually only go up halfway. And so what that changes is now our amplitude is 0.5 units. So this is all the same. This is all the same. This one that I wrote in is all the same. So our median line for all of them is y equals 0. Our period is 6.28 units. Horizontal shift is no for all of them. So what you can figure with the summary, the letter A, which is what we were changing in all of these, the letter A represents the amplitude. The entire curve will rise and fall A units above and below the median line. So D, we know, represents the median line. A represents the amplitude. These are things that you'll kind of need to remember. So on to the next page, characteristics, lots of them. So it says 3, follow the same directions as in question 1. So try doing, the first one's there for you, it's that same graph, y equals the sine of x. Try doing the next 3, actually the next 2, because the second one's there as well. So now what we're changing from this graph to the next is now there is a 2 in front of the x. So we're actually changing the b value. So see how that changes your graph. So pause the video, try the 3 other graphs, and then we'll look at what that does. All right, so back to it. So again, the second graph was already in there, but you needed to determine what was actually happening. So versus our first one, our median line is still the same. It's still y equals 0. Our amplitude, again, how much it goes above or below the median line, still 1 unit. And so where our difference comes is the period. So I guess I should just use my hand. So here, from one starting point to the next, we said was 6.28, or you could have done from one maximum to wherever your next maximum is, 6.28. Now what we have, it's from one starting point to where it repeats itself, it's actually 3.14. Or if we did from this maximum to this maximum, again 3.14. Or this minimum to this minimum, again it's 3.14 units. So what we've done is we've actually changed the value of the period. Basically what we've done with this one is we've sped up how long it takes for the graph to repeat itself. And again, the horizontal shift, since our starting point is still on the y-axis, there is no horizontal shift. So when you get to the next one, again, now we have the sine of 4x. So when you would graph out y equals the sine of 4x, it's going, again, you can look in my notes, it's going to be going way faster. And when you would do that last one, it actually is like way more spread out, or it doesn't even look like it's repeating itself if you have your window in the wrong spot. So our characteristics, again, our midline is still y equals 0 for both of these. Our amplitude, it's still only going 1 unit above or below. 1 unit above or below the median line. Still no horizontal shift in either of them, but the difference again that we're seeing is the difference in the period. So with that y equals the sine of 4x, again, if you calculated from one maximum to the next, so finding the coordinates of two different maximums and then subtracting the x values of those coordinates, it's actually 1.57 units. And in the other one, you might have to stretch your window out a little bit, but finding the value between two maximums or the value between two minimums or starting point to starting point, we actually would get 12.56. So our summary for this, we can see that changing the b value, so that's the value in front of the x in your sine function, changes the period. So when a sinusoidal equation is written in the form y equals a times the sine of bx plus c plus d, the letter b changes the length of the period. So the entire curve will expand or compress horizontally. So again, that's saying if this was our original line, what it means by expand is it'll go from that to this, or compress is like it repeats itself faster, if that makes any sense. So the period is equal to, what have I done? Forward. The period is equal to, so this is on your formula sheet, 2 pi, yes, that's pi 3.14, divided by b. Or the other way that you can write that, or b is equal to 2 pi over the period. So looking at what that means in terms of the context of the questions, sorry, why won't it let me erase? So for this one, so for the third graph, let's look at what that means. So b is equal to 4 in this case. The period isn't equal to 4, right? The period is definitely not equal to 4. So b is equal to 4. And as we have written here, b is equal to 2 pi divided by the period, or, whoops, I probably actually want to use this formula since I have b. So period equals 2 pi divided by b. So 2 times 3.14 divided by 4. So when you put that in your calculator, you should get 1.57, which is what we had up here, 1.57. So the length of the period was 1.57. All right. You know what I'm going to tell you to do. The last one, figuring out how it changes when we change the c value. So we've dealt with a, b, and d. Following the same directions for the fourth set of graphs is now we are changing the c value. So we've gone from our first graph that we've seen so many times. Now we're changing what's in our sinusoidal function there, adding or subtracting, I guess, as well, from our x term. So I didn't say it, but pause the video, do the other 3 graphs, and look at how the C value changes. So when you would graph it out, 1, 2, when you would graph it out, what you would find is, oh, I guess I could go back to the last page. What we see here is it changes where our graph is. It's shifting it to the left or the right. So when I've changed this, we've gone from a graph that's here with our starting point on our y-axis, and now we've shifted it, and now our starting point is not on the y-axis. We see that on our y-axis is pretty close to our maximum. So that's what's actually changed. These are the same, these are the same, these are the same. Yes, it now has a horizontal shift. When we would graph this one, it would suddenly be, I don't know how it's all drawn, but now our starting point, it's kind of over here and it's on the other side as well. It's a hot mess. So these are all the same as above, but now we have horizontal shift associated with it. So usually the way the questions will be phrased in these is just, does it have a horizontal shift? You usually don't need to calculate out what the horizontal shift is or where the graph will be, but all that a question will say is, does this graph have a horizontal shift? So what you'd need to do is look if there is a C value, and it will be shifting it either to the left or the right. So the starting point moves if there is a C value. Again, the starting point on that up swoop of the line, if there is a C value. Oh my gosh, this is so long. So there's a little summary part that says sinusoidal summary and practice. So these are kind of the keys for drawing and analyzing a sinusoidal function. So when a sinusoidal equation is in the form y equals a times the sine of bx plus c plus d, then your median value is the line equal to d, your amplitude is equal to a. Your period is related to that b value, so either period is 2 pi divided by b, or if you have to figure out what b is, so if you're given the period, if you need to figure out what b is, it's 2 pi divided by the period. And a horizontal shift is the graph moves left or right if there is a c value. And so I think, yeah. So when analyzing a graph, locate the median line. So again, the way that we locate the median line is find the maximum or minimum, and again, looking halfway between that maximum and minimum. Determine the amplitude. So the way that we find that is your maximum value subtract your median value, or your median value subtract your minimum. Determine the period. So looking at the distance between 2 maximums, or looking at the distance between 2 minimums. And locating the starting point is number 4. So the point on the median line, which is also on the upswoop of the curve, closest to the y-axis. If the starting point is not on the y-axis, then it has been shifted and the equation has a c value. So you have homework on the next couple of pages that you should be working on. Again, the key is on D2L that you can look at. I know the third graph is kind of messed up. There's a little speech bubble that says, this graph is incorrect for the given equation. Draw the correct graph for the given equation. So can you just fix that up? And yeah, so peek over that, send me any questions you have. You guys are the best.